In this one, we're going to talk about Python's object orientation, information hiding, function variables, comprehensions and generator expressions, decorators, docstrings, PyPy with an I, that's PYPI, some tools to help with Python software engineering, and links for further study. This is the last video in this series. So, object orientation. Object orientation is, of course, a large topic. I'm not going to try to cover it all here. In Python, it's accomplished with a class statement. That's how you define a class, obviously. And an object is kind of like a jack-in-the-box, where you have inputs and outputs and internal state. So on the jack-in-the-box, you can turn the crank. You don't know what's happening inside the box, but eventually you get a little doll that pops out. Here's an example of defining a class in Python describing a point in 2D Cartesian space. So you just have an x-coordinate and a y-coordinate. We define a dunder add, which will allow us to add 2 points with the plus operator. We're defining a magnitude method, as well as a dunder len that will be an alias for the magnitude method. And we're defining a dunder stir, which will output a textual description of a 2D point. Here's an example of how you would use it. Of course, if it's in a different file, you would need an import. But if it's in the same file, you could use it like this. We just create 2 points. We can print them. We can print their sum. We can print the magnitude of one of them, or the other if we want, but the example prints one. And the output is down below. Python supports inheritance. It supports single inheritance as well as multiple inheritance. Some people, including me, tend to think that inheritance is an overused feature. You're almost always better off using composition instead. So instead of having A inherit from B, you might have a attribute inside of A that is an instantiation of B. For multiple inheritance, you can use class foo of bar comma baz, and that will make foo inherit from bar and then from baz. So it will prefer the methods in bar over the ones in baz. And if you want to call behavior from a parent class, you can use super left-right.method of args to optionally pass control to parent classes. You may have noticed that in Python, def is used for 3 different things. It's used for defining functions, it's used for defining generators, and it's used for defining the methods of a class. The only real difference between functions and generators is really that in functions you tend to use return, and in generators you always use yield. And of course the defs of a class are within a class statement. Def and class are both executable commands in Python, and they create objects that you can manipulate. You can see that def and class are executable commands by stepping through a Python program with a debugger. We'll talk about debuggers later. In Python, everything is an object. Classes are objects, functions are objects, methods are objects. Even a simple integer is an object. So you can do a dir of x like this to get a list of the code and methods that are a part of the integer type. And you can say help of x to report documentation about x, in this case an integer. Python has limited information hiding. It's usually plenty, but it is not as effective as, say, Java's information hiding. Or Rust's. Yeah, Rust has even better information hiding. Even stronger. Labels in Python that start with an underscore just say, please don't mess with this. It's a convention. And labels in Python that start with a double underscore, but not dunder methods, not magic methods like dunder add, but labels that start with a double underscore are internally obfuscated to deter but not prevent client code from using them. Here's an example of function variables. Actually, one is a function and one is a class method, but we can call them with the same syntax, which is convenient sometimes. So we just define function, we create a class, and class has a method foo, and then we create a list with a function and a class method, a class's method, not a class method, but a class's method. And then we call each of those in turn with the for loop. And it simply prints 20 and 30. Comprehensions and generator expressions are not a tiny topic, but we'll touch on them here. A list comprehension is a way of creating a list from a generator or another iterable. Another, say, generator or list or dictionary, etc. Here we're just creating a list of all x's where x is in range 0 through 4. Only if x mod 3 does not equal 0 and x mod 5 does not equal 0. So that will give us 1, 2, 4. You know. And list comprehensions are eager. They will do what some people call a big inhale. They will build the entire list when the expression is evaluated. I'm going to jump down to the generator expression. It's the same thing, except it uses parens instead of square brackets, and it's not eager, it's lazy. So it only spits out values on demand, which means no big inhale, which means sometimes quite a bit better efficiency. And then in the middle there, we have the dictionary comprehension. We're just saying key is x and value is 2 to the xth. So we have 0 through 9 are the values of x with this eager dictionary comprehension. And x can be, well, first it'll be 0 to 1, and then 1 to 2, and then 2 to 4, and so on, up through 9 to 512. There is a third way of writing generators in Python. We've seen yield and generator expressions. The third way of doing it is both more time-consuming and more powerful, but rarely needed. It's really just a class with a dunder iter and a dunder next. But this is outside our current scope, but it's worth knowing it's available in case you decide you need it someday. Decorators are a way of applying behavior to potentially multiple callables like functions or classes methods. And they allow things like timing a callable or caching return values indexed by inputs or profiling. Numba has at least a couple of decorators for performance reasons. And there are many other things you can use decorators for in Python. Here's a quick equivalency between a decorator and doing the same thing without a decorator. In the first, we're just decorating fn, and in the second, we're defining fn, the same fn, but then we're saying fn equals dec of fn. Those two are the same thing. And dec, I'm not defining what dec does. It's just some arbitrary decorator like a timing thing or a profiling thing or something. Yeah, that's pretty much it for decorators. The reason that we have the at dec at the beginning is that it's kind of nice to know up front when you hop to a def that it's going to be decorated. You don't have to visually scan down to the bottom of the function or class's method to discover that it's being replaced with a wrapped version of the same thing. Here's an example of using a decorator. You probably know from Intro Computer Science that finding a Fibonacci number defined recursively is very inefficient in most languages. Probably all languages. I'll bet even something lazy like Haskell, it'd be very inefficient. But if you add a simple cache decorator to your find fib function, it suddenly becomes much more efficient. So that LRU cache with max size equals none is going to define a least recently used cache with no maximum size that will keep track of, for a given number, what the result was, what the return value was. And that makes it so that instead of having exponential growth, we have linear growth. And here's a nice URL about creating your own decorators. I'm not going to go into how to create decorators here. Docstrings are a useful part of Python, sometimes underappreciated, I think. A docstring is a string literal that is not assigned to anything. In particular, at the beginning of something, like a module or a class or a function or a class's method. And a docstring, the first one, is treated as documentation, which is used by help of module, for example, or help of FN or whatever. And when you do that help of module, it will output the docstring for module.py, or it might be in C or some other language. Also, a nice tool like Sphinx or Epidoc, EPYDOC, will extract all of your doc strings and output HTML or whatever other format documentation. And here's an example, a really simple example of using a doc string. Now, my presentation software has kind of mangled those quotes. It's simply 3 double quotes at the beginning and 3 double quotes at the end. They don't actually have to be double quotes, but there are tools that want you to use double quotes. PyPy is kind of like Python's CPAN for the Perl world, or Cargo for Rust. It contains many reusable modules that you can download off the internet with usually with pip or something similar. It's searchable and browsable at pypy.org. And here are 2 examples of using PyPy, PYPI, that is. The first, we're installing just one module, the treat module, and in the second, we're installing, all of the modules listed in requirements.txt. There's a convention in Python that when you have a bunch of modules to install, you put them in a requirements.txt text file, 1 module per line. And you may want to combine pip with a virtual env. I'm not going into virtual env much here, but it's just a way of defining an alternative namespace for installing modules into, so that you can have multiple programs with potentially conflicting versions of dependencies, all using the same interpreter version. Static analyzers for Python are very helpful. Some people say that Python is not strongly typed because it allows you to typo on a method name or function name, for example. Static analyzers are a good way of dealing with that problem. They almost completely eliminate it. Pylint is kind of the 350-pound gorilla of static analyzers for Python. It has checks for a lot of things, so many that I frequently find myself turning off a bunch of them. But it has checks that I am unaware of any other static analyzer checking, so it's probably worth adding to your continuous integration system or something. I like to just throw it in a make file and run it every once in a while from the make file. PyChecker, I haven't been the biggest fan of. I've never done a project with PyChecker, but it imports your modules. So if you import, if you PyCheck a module that doesn't have a name equals main, but it does have some statements at the module level, PyChecker is going to try to run those statements when it checks the file. That's why I've mostly avoided it. PyFlakes is nice. I like to integrate PyFlakes into my text editor. It checks for just obvious errors like function, well, a label, defined but not used or used but not defined, which catches a lot of simple typo errors. Flake 8 is a combination of PyFlakes and what is now called PyCodeStyle. I'll talk about PyCodeStyle in a bit. We already touched on MyPy, but MyPy is also a static analyzer, and it's good for checking type annotations with various degrees of stringency. PyCodeStyle is formerly called PEP8. It implements a lot of the PEP8 Python Enhancement Proposal 8. Python Enhancement Proposal 8. Python code style conventions. It doesn't require you to do everything in certain ways, but it does catch a lot of things that might otherwise result in source code control system churn unnecessarily. And PyDocStyle is another static analyzer that just looks at your doc strings and makes sure that they conform to certain conventions. And finally, Bandit is a security-oriented Python static analyzer. Python IDEs, a lot of people really like PyCharm. I don't use it, but I have tried it. I found it a little bit frustrating that its hotkeys were different across different operating systems. So when you Google for information about how to do something in PyCharm, you tend to get the Windows version of how to do something when what you really want, or at least what I really wanted, was the Linux version. There's also VS Code with the Python extension, which is very popular. That's, of course, Microsoft's Visual Studio Code open source project. I tend to use Vim, which is VI improved, with the Syntastic and Jedi plugins. Syntastic allows you to hook in things like PyFlakes and PyCodeStyle, and Jedi allows for nice tab completion if you hook it into SuperTab, so that you can autocomplete your identifiers. And some people really like Emacs with LPy. I haven't tried it. I've tried Emacs. I haven't tried Emacs with LPy. Python debuggers. Of course, PyCharm has a debugger plugged into it. It supports remote debugging, which can be nice. I usually use PUDB, which is the Python Erwid debugger, which is basically an ncurses GUI. So you can run it without X forwarding, without any X11 libraries installed. All you really need is SSH. And it's pippable. You can pip install PUDB into your virtual environment, or into your home directory, or into your interpreter's default namespace. And there are many more debuggers. Those are just the two that I hear about the most. Some further resources for studying Python. Dive into Python is good and free. Python koans is nice. It's kind of like the Ruby koans thing, where you just have a little snippet of code that has a problem and you're supposed to fix it. A whole bunch of snippets, actually, that are intended to teach a lesson. Here's a Python cheat sheet. Cheat sheets can be very nice learning a new language. Here's a list of Python dunder methods. We talked about a few of them, like dunder add and dunder stir and dunder init. Here's a nice big list of them. And Python is a very Googleable language, so of course Google is very nice for finding answers to questions. Um, Python list, which is also a gateway to complying Python, is a useful resource. It doesn't see as much use as it used to because of Stack Overflow, but Python list is still useful. And of course, Stack Overflow is a good place to pick up Python and get questions answered. And so is a local Python user group. Here's a Python on Windows FAQ. Here's a nice article about why you should use Python. It's a bit dated now, but it's still a nice article. And here's an article about why you should learn Python. And that's it, folks.